Hi, welcome to this Open Security Summit session in March 2022. And here we have a very, very important topic on the idea of scaling security. And Elizabeth and Kevin are going to talk about a tool and a project they're working on. But I feel that this is definitely one of those areas that if you want to be involved in the next major revolution of security and how we actually going to scale this thing, this is definitely the place to be. So over to you.
Oh, thank you so much. Well, thank you for having us. It's been an amazing week of talks and idea sharing, and really delighted to be here. We'll probably go through a bit of this talk and then open it up for group discussion and questions, because we're really here also to hear ideas from the community. And we're just really excited to share our free and open source project called AppMap with you as well. So thank you very much for that introduction. We can talk a little bit about who we are. I'm Elizabeth Lawler. I am a serial entrepreneur in the dev tools and DevSecOps space. Before getting into startups about a decade ago, I was a chief data officer and security officer at a healthcare startup. And before that, I spent almost a decade doing big data stuff in government healthcare and IT and trying to secure our systems from being hacked by the Chinese. I learned programming while I was doing my master's and PhD in epidemiology and biostatistics. And I used to have to explain what epidemiology was, but after the last 2 years, I'm sure everyone knows what epidemiologists do. Actually, I left because I didn't think it was a growth industry. I probably should have toughed it out, but I'm actually most happy to be here in the DevSecOps and Dev and security community again after a little bit of a hiatus. So, Kevin?
Hi, I'm Kevin, Elizabeth's co-founder here at Appland, longtime dev, etc. Elizabeth and I previously built Conjur, cloud-based, secrets manager that was acquired by CyberArk, and I had many jobs in software development before that, going back into the sort of late 90s. And I own a 1954 Cessna 170 tailwheel airplane that Elizabeth says I never stop talking about. So
if you're interested, if you're interested in birds of a feather about airplanes and airplane safety.
Yeah, check out my Instagram.
So we are currently working on a free and open source tool called AppMap, which is, you can find us at Land of Apps on Twitter. And it's really a tool we describe as Google Maps for developers. And we're going to be using some examples from this project in our talk today. It's an OSS project with an MIT and Common Clause license. And really, we built it to help developers understand and improve applications by understanding their design and architecture better. And that includes application security. We have, it's a code editor extension for VS Code and JetBrains. And we also have a CLI only installation flow, so stay tuned for that. But the genesis of this project was really kind of that, when you step back and we talk a lot about how we struggle to communicate about various issues that are design in nature or security in nature, and we're trying to get a lot of people on the same page. Maps are just a great tool for exploring and analyzing application security and application security vulnerabilities. And maps can make it easy to spot problematic code or database commands and then navigate to the root cause. And our goal in this was to reveal the blueprints of the code in its application.
Can I say a little thing?
Yeah.
So this is the stuff that I always had in my head when I was talking about security, that everybody thought I was completely insane. And I knew in my head, because I've done some of this stuff in the past, but I always knew that the only way we're going to scale is when we are able to programmatically visualize and understand what's happening, and we create this stuff from code. And this is like so spot on. Makes me so happy that we get into this world, because fundamentally graphs, we need to evolve it into maps. You need to get into worldly maps. But the graphing part of this opens up so many opportunities, because then we can scale. These will allow the content to be correct, to represent reality. And then there's so much stuff that you can do on top of it. So yeah, no, I couldn't be more excited. Sorry.
Oh, that's great. I'm so excited that you're excited because it really is about lowering the cognitive burden of people to get aligned. And we're going to talk a little bit about what that really means and actually how maps both can help and contribute to cognitive burden problems. And so it's not only our maps, it's not only just the mapping, it's not just the pictures or even the data that underlie the pictures. It really is the maps plus the process that really help you to get to that alignment. And we need more assistive technology, I think, because it's really too much information.
And remind me, you coming from the AppSec world or from the development world?
Well, we've always worked at the intersection of both, actually. So when we think about our last project, Conjure, what we were looking to do was to ease the burden on developers of thinking, of where do I put a secret? How do I manage the life cycle of secret? How do I handle all this security material that I'm constantly got in my face? And then from the security perspective, we need processes that do privileged account security that can handle non-human actors and highly automated workflows. So we've always worked at the nexus of these two issues. And I think, again, we're doing that, but this time we're trying to service a different set of issues. And we're actually, I think it was in the abstract of our talk, we're really focused on the things that are kind of like rising in prevalence in terms of what are the more common or more complicated issues that are becoming more frequent, and how can we address those?
Yeah. So what I would say is I think security can be a great driver to create this, because, for example, if you look at threat models and understanding, but the real consumers will be the developments, and they need it, especially this crazy idea that you don't need documentation architecture diagrams if you do agile, which is just insane. But insane. And they have a point, because we cannot take a week to create an architecture. I agree, but without this, it's suicidal, which is what happens to a lot of situations. So I feel that the real driver for this has to be the developer teams, and you want to have mandates that this happens natively. But the security teams are the ones that can immediately push and enforce our requirement, because they need this for threat modeling. They need to understand the attack surface, and
totally.
And I think that's the sweet spot.
Yeah. So if you actually look at go ahead.
AppMap, we're focusing on security here, but as you're noticing, it's developers who need to, write and fix the code. And AppMap, it does a nice job of showing security issues, and we'll do plenty of live examples throughout the rest of the talk. But it also highlights performance issues and maintainability issues and things like that, which are like also of relevance to developers.
Yeah,
and if you look at our installation base today, so we released AppMap as a VS Code extension in March of last year, and then we released it following as a JetBrains extension. So we put it right into the code editor. And we have over 12,000 users today, but they're developers primarily, I would assume. And they're using it to understand issues that are brought to them. What I think is an even more effective approach is to use AppMaps as a vehicle to describe issues and then get them on the fast flywheel for fix. And we're going to show you kind of how that works.
Cool. Yeah, go for
it. All right. Next slide. Oh, and I think yeah, go ahead.
Yeah, I want to talk a little bit more about what's in AppMap, and then we'll be getting back to, we'll be taking a step back. But just to kind of set the table for where we're going with this, AppMap is really focused on web application backend. So we started out thinking about visualizing code. It's better with a focus, and that focus for us has become your web application backend. So all the CWEs, OWASP, and all that stuff, like that's all relevant for us. AppMap's not something you're really going to use to analyze like your mobile app or your video game code or whatever, or even right now like your JS front end. So, but it does, that's enabled us to focus specifically on these backend frameworks that are like the most powerful web frameworks. And AppMap has a bunch of intelligence or knowledge about these different frameworks built into it so that it can recognize things like this is a HTTP server request or client request. These are the headers. These are queries. You know, this is the model view controller architecture, and here are those layers. Here's where the app is performing serialization or handling secrets or starting a background job or authenticating the user. So these are, if you're going to look for performance or security issues, like it's not good enough, we found, to just show all the function and all the function calls and how they fit together. Like that doesn't give people enough of a handle on what's going on to really understand like the app. So let me show you like an example of what this looks like. So this is an AppMap. AppMaps are, unlike a static analysis, an AppMap is created from recording code execution. So it's really a code execution and data flow map rather than just a source code, hierarchical code tree, and file name map. So that's what you're looking at here. You're looking at the password reset flow for the Rails sample app, which is a Twitter clone that's used to like teach Ruby programmers about Rails. And we can quickly kind of check out some of the features. So one thing to notice here is that there's a dependency map that in this case shows you how the inbound HTTP server request flows through the framework into application code, like the controller, through like a view layer that it makes SQL queries. And if you look over here, you know, you can see all those queries that are issued in detail. So those are some of the things that showed up on that slide a second ago. There are several different requests that are all made in this flow, which was like a multi-request flow of a user going through like an entire process of resetting their password. So it wasn't just one web request; it was a sequence of them. I mentioned how how AppMap has knowledge about the frameworks that are listed a minute ago. So it knows about cryptography and where data is being encrypted or decrypted. It knows about deserialization of data and whether that's being done using a safe method or an unsafe method. It can find interactions with the HTTP session, logging. It can find places where the code is like issuing or handling secrets, where it's performing authentication. And for all of these, because it's a code execution, now I've switched over the tab up here from dependency view to trace view. So now we're actually seeing the code flow in the sort of sequential order that the functions get called. So first there's a controller function that gets called. It writes a log message. It makes a SQL query. It's creating a reset token, and that ends up calling this function here, which issues this token string that you can see over here. Again, because it's a runtime analysis and not a static analysis, you actually have like real data values, and AppMaps contain those data values as the code execution proceeds. So does that seem like a good overview, Elizabeth?
Yeah, and I think so. What we're going to do then is talk a little bit about why, how we envision this could potentially be helpful in working with developers and communicating different kinds of findings. And then, yeah, we're going to go through some specific use cases of how you can actually use the underlying data as a method of interrogating, even in the development environment, when someone's making a change that would be considered adverse.
Okay.
So I thought perhaps we might go a little bit into like, why did we even bother starting to do this? And why, really what are the kind of key trends and movements that we're aligning with? And, when we started our last project, which was Plunder, plain text secrets in source controlled were the number one security issue. So we're still interested in aligning ourselves with some of the kind of more popular movements of what's going on in AppSec and what's going on in development. And the ShiftLeft movement is like kind of primary about it, right? It's really about involving the code developers as owners for more aspects of code quality, including application security. And it's just so hugely important. You were talking a little bit earlier about the security champions programs. You know, we've been able to use education, automation, and tools and techniques of DevOps and DevSecOps in this movement. And it's just really kind of where we come from as we're approaching building AppMap. The second is really the observability of software. And there have been so many different talks about that. I think we need more assistive tools to help us understand how these complex systems work. As Kevin was showing you, just even all of that information that we were reflecting back out in AppMaps, it isn't really always top of mind. It's not always easily available for developers while they're thinking through problems. And that was something we wanted to talk about. And the third item is really a trend. And so we'll talk a little bit more about that below. So let's go to the next slide. So ShiftLeft for probably this group of people who are working in Kevin, can you go ahead one slide?
One from here?
Yeah, one from here.
Are you seeing movement one shift left?
Oh yeah, there we go. Sorry, it took a minute for it to come up on mine.
Okay.
Yes, movement one shift left. So much. Oh, Claudius has a question too.
No, that was just me commenting.
No, there's a hand raised.
Oh, sorry.
So I'm going to keep talking, but hopefully Claudius can get his question opened up by the controller. I'm not controlling it. You have to. I think you have to let them ask the question.
Oh, it says.
So I'm going to keep talking, and we're going to get.
But what happens when someone raises their hand? Like, what do we do? I don't want to just blaze through this.
So Kevin.
Claudius, can you ask the question on the chat? But I think Alona, you're still here, right? Or if you can make me a host, I can.
I'm not a host, so I can't do it.
I know. Can I reclaim host? I think I can. Give me a second. Keep going.
Okay, so ShiftLeft, we all probably know about this, given the work that we do. What's really interesting is there was a paper in January, which came out of a group at Meta, particularly it was the WhatsApp group. And it really just hammers home, I think, the data about why ShiftLeft really matters. They have a runtime tool that looks for, I believe in this case, it was performance impacting issues. And that they found that if the flaws were found in test or prod, only 20% of them were fixed. If they were found in the coding and at the coding time or in development, 74% of them were fixed. And I think it's just, my question was that chat was disabled. All right, I think we've got Claudius's question. Yes, I think hopefully chat is enabled for everyone.
All right, sorry, I just enabled. There you go.
Okay.
Well done, Claudius. All right, I just enabled chat. Sorry.
Yeah, so really, it's the issue here that one of the issues that we're hopefully going to be able to address is by putting all of this information about runtime into the developer's environment, we can help to provide more context for developers to be able to find and fix flaws with the context that they need in kind of yes, it's gonna be in the deck, Claudius. We're gonna be able to find and fix the problems earlier. Top 25 issues are coming up next. So yes, so the goal is here to be able to optimize for the developers thinking and action in the development coding moment as much as we possibly can. So that's why we put AppMap in the code editor. Next slide.
You know what I'm going to do is can I just do this?
What? Oh no, yeah, you can. So
All
this
right,
is what
I'll
we're
just
talking
put it in
about,
the chat.
paste it in there. Yeah.
All right, there we go.
All right. So the next movement we were talking about, which it's been all over this summit actually, is observability and visualization. And it's just like this kind of perennial, how can we understand our software complex systems better? How can we understand what our code's doing better? It's so interesting how much of this has been talking about. So, I really look forward to extending this conversation with more of the folks who are interested in these kinds of issues. And what was even more interesting is that not only was it talks about success cases, but it was also talks about failure cases. So it's clear that we all clearly desire more tools to engage with the information and communicate more effectively across our teams. And there are some interesting opportunities and gaps there. Next slide. So, and the reason I think we all gravitate to visualization is because really what we're trying to do is replace individual mental models. So we don't have to create, keep complex relationships in our heads. And so if you think about the role of these maps, and I mentioned this before in our little back and forth, is that they're really cognitive artifacts, right? Their purpose is to lower the burden of how much information we need to hold in our heads to be able to think about a problem. And our real purpose of using maps is to try and improve our own performance, right? And they're there to improve the performance of us as a group, and also ideally to improve our performance in our own individual work. And so oftentimes when we start a mapping project or we start an analysis project that involves diagrams, we usually start at the kind of how are we going to help the group? These could be system level diagrams or holistic UML diagrams that can span entire walls or huge whiteboards. And what we're doing is trying to collect a lot of information so a lot of people can use it. And they're often very challenging and expensive to make. But the large and complex diagrams can also be rather difficult to interpret because they are difficult to translate into direct action. So the goal there is to not only be able to have a holistic data model that can make a big map, but also be able to trim that information down to make a small map. I would liken this to kind of Google Maps, and this is why we talk about Google Maps and we use it as a design principle. If I want to drive from Boston to San Francisco, I can have Google map the whole entire way with all of the delays and everything as I make my travel. But I don't try and consume all of that information at once. I actually probably only need to know about the next 10 to 15 minutes of driving and what path that looks like in order for me to avert problems. And so you need to be able to toggle between scoping out to the entire mapping problem and scoping down to the individual's action. So I think that's what we try and find a way to create some parsimony in AppMap about having a system level view versus an individual work level view. And the last topic I want to talk about is trends, is a trend. And when we had our last project, which was Conjure, which was addressing this plain text passwords in source control security issue, that was really where we focused our effort. And I think if you look at the current CWE top 25, or you look at what's trending in terms of security issues and application security issues going on, it's really interesting how over time, I think we've developed enough success around identifying issues that can be addressed with the current tooling, that really what we have left and what's on the rise is the stuff that you can't identify with the current set. I mean, it kind of makes sense, right? It's almost like if you have a set of safety nets and you can't, and things pass through, what you have left over is something for which you don't have good information, data, or timely insights. And that's really where we think AppMap can help in application security. And a lot of other people have talked about some of these issues, like the proper implementation. The person who's talking about OWASP top 10 and how to educate your developers about issues of authentication and authorization. It's really, these are the remaining issues, and they're more complex. They're often only seen in runtime and using runtime data. And so that information isn't readily available to developers while they're coding. So we really thought about how could we bring that new information, that new data resource, and put it right in front of the developer while they're in the coding act so they can react positively to different kinds of suggestions we could potentially be making, and that they could investigate the behavior of their application in that moment. And that should lead to faster cycles of fixing and fewer bugs or defects making their way off of the desktop and into the tester production environments. So, you know, I really think that's kind of the final leg of the stool of what we've been trying to build. Next slide. So, as Kevin mentioned before, it's really about runtime code information, code execution information being put into the developer environment as early as possible, so they can see how code will behave while they're coding it. And that, again, should lower the cognitive load for the developer to understand the kinds of issues that we're talking about, because they're not readily available in static code analysis. It's in the code editor, so it's super shifted left, and it has the kind of information we need to find the right crop of problems that we want to alert them on. So this is that mechanism. This is what we've created, and it's a little bit kind of like an APM, but with deeper code linkage and a bit like a static code analysis tool because it works in the IDE. So does anybody have any questions about that?
What's the IDEs they support?
JetBrains and VS Code, but we have a command line only tool now. So it will now start to work with any code editor or even just in the terminal.
Cool.
So yeah, so then let's talk a little bit about what runtime, these kind of runtime data analysis can find in terms of flaws. Do you want to do this one, Kevin?
Sure. So this is an example that we created by scanning the same app with two different tools. The first one is the Brakeman static analysis tool, which has been around for like eight years, probably, like quite a while. And then the second scan on the right is with the AppMap runtime scanner. So, you know, we just wanted to sort of make it really concrete that a lot of the issues that Brakeman would be finding like 7-8 years ago, a lot of those now are all kind of worked out in the frameworks and in the tool support. And so as I've gone, you know, digging through Brakeman, you know, to see, to learn more about it, like a lot of this stuff actually, if you're using, you know, modern and the, you know, relatively recent, you know, within the last 4 years or so, versions of libraries and frameworks, like most of the things that Brakeman looks for are not going to be there because they're in CVEs that have been patched like quite a while ago. So that's the reason why we have findings on the right-hand side that are relevant to the CWE list, things like unsafe deserialization of data, a secret in a log file, HTTP request that doesn't have authentication. Those are things that were outside the scope of Brakeman's like static analysis and most static analyzers. So, you know, this kind of brings home that there definitely, in our view anyway, is evidence for that there's a place for this runtime scanning and that there's important stuff to find in there, even when the static analysis results are coming up clean. So, and we'll dig into this stuff a little more with some demos. I'm not sure how far away that is at this point.
Actually, just now.
All right.
So now we're going to put together all the pieces: the pictures, the runtime analysis, and the CWE top 25.
Oh, you want me to do this one too?
Kevin.
Okay.
Yeah, you're going to do. Yeah, take it away. We're ready to put it all together.
Okay, so you know, we went through AppMap, and AppMap is something that we released in March of last year with the ability to record code, with those frameworks that I mentioned, and there's been a community of people who've adopted those for code visualization. AppMaps are just JSON files, so they're easy for people to share around. If you see something, you can put it in a ticket, you can drop it in Slack, and someone else can open that. And so the next step that we're taking is to actually look for those types of CWE issues in the code maps. And I was going to start by first showing what that looks like when you just kind of do it through inspection, not with really a tool helping you. So that's where I'll go next. I have a couple examples here. The first one is, and they each have a CWE. So this one is insertion of sensitive information into a log file. So in this case, so secrets and logs, right? So this is a good discussion of the CWE issue for that, 532. And this is a map of getting down into the details of if you want to have a definitive finding of a secret in a log file, then if you really want to be right about that, the way to do that is not to have regular expressions that look for things that look like secrets, or look at the entropy of the data, because there's lots of things that are randomish or random looking data that aren't actually secrets. So what AppMap is doing is a little bit different. So here we can see this function, user.newToken. Let me fix that. And you can see that what it's doing is generating a new secure random value, right? This is the user's reset token. And the value of this looks like this thing, DDVPY, et cetera. So AppMap knows that that the return value of this function is a secret. So that's the first piece of this finding. The second piece is understanding what all the log entries are. And so logging is performed through functions. In this case, it's the Logger log device. And so there's a log statement here: started patch / passwords resets / and then here's that reset token that was issued earlier in the code flow. So this isn't a guess or an inference or a pattern match of a secret in a log file. Like, this is definitely a secret in the log file, because it's actually being used as part of the URL route that you can see here, patch password resets ID, and the ID is actually the reset token. So first example. Let me move my little Zoom thing here. All right. So actually, let me say one more thing about this. So because the generation of the secret is over here in the code flow, and it's event 381, and the secret gets written to the log file in event 1045. Like, these are pretty far apart in terms of like time and space, and that's why this is not amenable to static analysis. Static analysis tends to look at functions or code structure within functions, or maybe like a small neighborhood of functions. So AppMap, because it's looking at the actual information flow, it doesn't have to sort of compute or guess or reconstruct like what the functional flow looks like the way that static analysis does. It just observes. So that'll be evident in this next one too, which is also an important CWE, missing authentication for critical function. So naturally, and they have an example down here of like creating a bank account. Yeah, you probably want to make sure you've authenticated the user before you create a bank account. I don't know if this is a real example or not, but a lot of the ones in the CWEs like are taken from actual CVEs, and that's one of the reasons we link to this information, because you can go find like the real CVE reports that led to the creation of these items. But it's kind of hard, especially with static analysis, to detect the absence of something. Like, what does it mean to be missing authentication? If you consider looking statically at a code base, you have some routes, you have an authentication function, or maybe it's provided by a third-party library. That doesn't tell you for any particular request flow whether that authentication is going to be applied or not, or how it's going to be applied. Or one of the other CWEs is if you authorize the user's permissions before you firmly establish their identity, that's a security flaw. And so the order of which things happens is important. So in this case, there's a route to show user info details. And as we step through the functions here that check and see if the user is logged in, there's this logged in function. There's a label here, security authentication. So we know that's what it's doing. It's ultimately looking in the HTTP session with the user ID key to see if that user is present. And when in an AppMap, when a function returns something, you have this little return value indicator over here with the value, which in this case is just an empty buffer. So there's nothing here. So the user's not in the session, either here or in the next time that it looks for a user. So the upshot is that while there is an authentication step in this flow, it doesn't find a user, and the application code is fine with that. It continues executing through and serves the page. And the way that we know that is that we can look at the status code here, and it's 200 status. So being able to pull together things like what's the URL request, what does authentication look like in this app? How do I know if it was a positive or negative result? And what is the server response? If this status was like a redirect to a login page or something, then that would be okay. It's saying, hey, no user, no dice, go over here and log in. So, it's not tremendously complicated, but it is important to have all those elements that we talked about earlier in the talk. If I'm going to do a third example, it would be this one, deserialization of untrusted data. So there are functions in pretty much every programming language that will turn text or binary strings into code in the program. And some of these are pretty unsafe. If an attacker is able to submit a specially crafted text or binary serialized string, then if the application unmarshals that, it will essentially unpack and execute code in the back end. So that's not good. And there's a bunch of examples here. I kind of keyed in on this one where an application gets some data. In this case, it's in an auth token, which is data that's under the user's control. It decodes that from base 64 and then loads it with this unmarshalling package called cpickle. Cpickle is unsafe, so if you send it a malicious auth token, you can perform remote code execution. That's what this says. So here's a similar thing happening in this web application backend. there's a login function here, checking if the user is authenticated. There's a token, which looks, tokenish. It's base64, a bunch of stuff. What it turns out to be is it gets unpacked into YAML, and the client has actually sent a payload containing Ruby ERB, which is like a code snippet, essentially. So when the backend loads this using the YAML loader, it will instantiate and potentially execute this ERB code. So again, not good. In all cases, we can see exactly what's happening, what the data is, where it's happening in the overall control flow. We can see which route it was. In this case, it's getting the password reset edit form. And that's lots of information for the developer to use in order to fix the problem. So that is that snippet. Yeah, so I've gone through a few of these different examples. What I haven't showed, which would kind of address also some earlier questions, is what this looks like in the development environment. In addition to the question of, okay, you showed me some flaws in AppMaps. How are people expected to find those? If you do a deep investigation of AppMaps, you can find stuff like that. But how are you going to do that for every build and every branch and every pull request, right? So that is what our new code analysis tool is designed to do. It's designed to automate the task of looking for these security anti-patterns in the app maps. This is VS Code. This is our AppMap plugin, which will actually render app maps in the code editor. So here's an example. This is the same like password reset flow. And this again is, this project is this Rails sample app that we found so useful for doing demos and kind of exploring, showing how the product works. So from the runtime here, now I'm in development, right? Like what I showed you before was in a web application. So something generated those code maps, pushed them to a website, then I can go look at them. That's not really what developers want. What developers really want is to be able to use any tool that touches or interacts with their code in their local environment. It's easier to make fixes like as you need to make them. So if I click on here, I can click right over to view source, right? I'm going from diagram like directly to code and back and forth again. As a developer, like you direct me to the code I want to see. That's good. Don't leave me hanging there. Like actually put me in the source file so that I can make changes, right? That's what I want to do. So that's why we bring these tools all the way down into development. The second reason the tools are here is that if you're going to provide me some code intelligence, some assistive, technology, do that here while I'm coding and working, so that the thing that when I ultimately push my code up to the server, like I've already fixed the problems. It's nice when, it's better to have problems get caught in the CI than to not get caught at all until they get into production. But it's much better still to fix them like while they're still on my machine, and it's faster and people aren't seeing my mistakes, which for me is great. I want to make those privately, and by the time I show you what I've done, like it looks like I'm just making magic all the time. So that's what I want. That's what I want things to look like as a developer. So what I can do here is I have this little script here, which is going to run test and scan. So it's going to test my code and run looks like I have something up there. Did I really like make an issue there? That looks like an N to me. There, back you go. Okay, so my test run is clean, and then I'm running these scans, and this is basically the same thing that I showed you in the Brakeman. In fact, I have that here. No warnings, all good, right? Yeah, there's some stuff found here, and it includes deserializing that untrusted data, secrets in log file, unauthenticated HTTP server request. So, of course, I can open those AppMaps here in my local environment, the same that I did up on the website. I won't go through like all the events and everything because I just did that. What I want to do now is really show a little bit more of like what the developer's workflow would look like. So being able to, you know, open up one of these app maps. Let's look at the one with untrusted data. There we go. And I'll go up here to password resets.
Kevin, we have like 5 minutes left on the hour.
Okay, I can do this in 5 minutes. And I won't rush it either. So here's a label showing unsafe deserialization. Here's that same event that you saw when I was working on the website. Here it is in the code, my user authenticated message. And what I'm doing is here, I'm doing the same thing that I saw in the CWE. So I've kind of done this deliberately now, which is to unpack the token and turn it into a data structure from YAML. Well, and then check if it's implementing the reset operation. So my extra cleverness of adding like extra validation that this is like the right kind of token, what I've actually done is introduce like a remote code execution vulnerability. So I'll go over, do some research, figure that out. I've got a couple files down here that I've prepared to like patch, in other words, fix these problems. So let me do that. This is coming over here now. It's just simplifying that code and taking my clever hack out. Retest and scan. Now I've got a clean bill of health with those findings and issues, you know, remediated. So at this point, like I've made my mistakes privately. I fixed them. When I push this code, everything's going to look good. No one will ever know, you know, that I tried to do that. Or if I did, you know, it gets caught in CI, and I have, you know, I have a, as Elizabeth said, 75% chance, if not more, of, you know, being able to find the time and inclination to get that issue fixed before I'm pushing it up for all my, for it to potentially go into production, which is what we don't want.
Totally. So in the last 5 minutes here, I'd like to just open up the floor to questions. And because I think this kind of shifting left is really here to stay. And I'm curious to see what, what people think of this kind of workflow, what they think about trying to put this kind of information right in front of the developer with that kind of context. And if there's any interest in talking about what more you'd want to see a developer exposed to while they're coding with this kind of information to find and fix security flaws. And who wants to? Anybody want to jump in or make a suggestion or?
Sorry, if anybody wants to chat, I can unmute you guys, give you co-hosts. So do you wanna bring the people in from the Rafael, you wanna? I'll make you a co-host if you wanna ask more questions or.
Well, what do you think?
I really want to give it a test drive, I have to say. I think you are in a great intersection of the within the static analysis and the kind of stuff you can grab from the code. So I really want to. I think it would be great to do a hands-on session next summit. We fire up, something like one of those sort of environments that we can share code. And if you have a couple like almost use cases and everybody has their laptop and you can just start going through and trying to detect it and basically replicate the thing where you just demoed, right? Because I think that would be quite useful.
Because the nice thing is we can actually break this workflow down. So the rules, for example, they're just they're little files that you can write in TypeScript and we can amend them. Like people can make them work for their own organization. And then the workflow that you see kind of going through is really what I don't know how to better describe it. It's like an experience you're pushing on your development team. Do you know what I mean? Yeah. You're like, hey, buddy, look at this thing over here before you check that in, And so that's the part, that's the last mile, I think, of trying to get things not only detected, but fixed that we're really trying to focus on, I think, with that.
Yeah, I think that's the one that I think will be really interesting to sort of fix from beginning to end, because that's, that's the, the flow or maybe look at it from an incident point of view, or there's a vulnerability here and we're just going to use this mapping, because I found that I'm a big fan of using incidents strategically, and this is a good example of you can basically fundamentally almost use this in an incremental way, because I think the challenge sometimes here is that where do you start? Like where do you go? And mapping everything feels so abstract, where if you find with a bug, it's sort of like, okay, let's just map the bug. Let's just map that particular issue, or use that to discover security vulnerabilities. Like how do you find the vulnerability? So because you kind of almost know, I know that there's a problem here. Like I've done things in the past where I would write tests at every layer until I found the bug. And that actually helped me to almost be trimming down where the problem was in a way that I couldn't manually. And this, I think, has the same property. So if you have some of those use cases, I think that'd be quite cool.
Yeah, definitely. I think that gets to both the promise and the challenge of using maps, right? When we were talking about it, like you can use big maps to explore for things and find stuff. But then when you're trying to change someone's behavior, you're trying to say, turn right, don't turn left, don't do this, do that. You actually have to scope the map down really, really far to, like you were saying, just to the bug. And that's the workflow that we're trying to work through as we develop this project. And like I said, it's free, it's open source. All our stuff's up on the public repos. If anyone wants to kind of come take a look or issue bug, if you find a bug in our stuff, issue a put a GitHub issue. But yeah, this is a conversation we're really interested in having with the application security community, and we really appreciate you having us here.
So next session, you put AppMap on the title.
Yes, next session I'll put AppMap on the title. I'm sure the marketing department's going to kill me.
It's open source, right? That's the thing, right? As long as it's open source, it's cool, right? It's no problem at all. Look, I'm not sure there's any other questions. Let's just double check. If not, look, thanks for you, for everybody that participated. I think I'm really looking forward to see the next steps and see the intersection, and let's explore those collaborating sessions.
Awesome. Thank you so much for having us.
Brilliant.